Okay, so to find the intervals of increase and decrease, what you want to do is you want to go to the leftmost part of the actual graph. So we have this graph. The leftmost part would be over here. We have this arrow here, so this means it's going forever towards negative infinity. So let's just pretend that we're actually on this graph. And we're just going to walk along the graph and see if we're going up a hill or down a hill. And that will tell us if we're increasing or decreasing. You always read increasing or decreasing from left to right. So you start at the leftmost part of the graph and move to the right. And just determine the x values for which you're going up a hill. Those would be your intervals of increase, and then the x values for when you're going down a hill. Those would be your intervals of decrease. So let's get started. So this graph goes on forever to the left. So we're starting at negative infinity. And as we begin to walk, we can see that we're going up a hill. So we start off increasing. So from negative infinity to some value. So let's just keep going until we're no longer going up the hill on this x-axis. So we're going, and it looks like we have this asymptote here. So we know this graph is never going to cross this asymptote. So we can see where it is. It looks like it's at positive 3. So we'll get really close to positive 3, but we'll never touch it. So we're increasing the whole time from the x values of negative infinity all the way to positive 3. So anytime there's a break in the graph, you're going to have a new interval of increase or decrease. We definitely have a break in our graph here. So you basically kind of just hop over and start the new interval. So where does this one start? At which x value? Once again, this is an asymptote that this graph never crosses. So this piece on the right of the asymptote gets really close to the asymptote, but it doesn't actually touch it. But if we were to hop over to this other side, we could see that we are actually going down a hill now. So we're decreasing. So we're decreasing from the x value of 3 all the way to this arrow goes forever to the right. So we're decreasing all the way until infinity, so forever. So that's the gist of just finding your intervals of increase and decrease. Walk along the actual graph and then determine if you're going up a hill or down a hill. Now the domain and range is kind of similar. Let me erase the stuff we drew on the graph because we're going to need to do some things here again. So what you do for domain and range is you actually start out on either the x or y axis at the smallest value. So we go all the way to the left as far as we can on the x axis to determine our range, or to start to determine it. So that would be all the way over here is negative infinity because it goes forever. So say we're here and we start walking. We just want to look up or down to see if there's actually some graph there. So because this goes on forever, because of this arrow, we would see a graph there. So that would be included in our domain. So the negative infinity and we're going to walk to the right. And we're just going to keep looking up or down to see if there's an actual graph there. And if there is a graph, then those x values are included in our domain. So as long as we're moving from left to right, we can see in this graph that if we look up, we still see this graph here. And we'll continue to see a graph until we get to a certain x value, because this asymptote, we know there's no graph that actually crosses there. So this value of x is equal to 3 is not included on the domain. So we'll get to 3, but we don't include it, and we show that using an open parenthesis. But then it picks up on the right side of 3. Remember, this graph gets really close to 3, but it doesn't actually equal 3. So to show that in interval notation, we go from 3 to infinity, because this continues to show a graph. If we were to continue to walk this way, the break in the graph is at 3, so we don't include the x value of 3, and then it picks back up where we see a graph all the way to infinity. And it's the same idea for the range, except for the range you start at negative infinity down here on your y-axis, and you go up and you look left or right to see if you see any graph. So as you can see, if we look left or right here, there's no graph anywhere. We don't actually start to see a graph until we get to, or really close to, this y value of a positive 2. You can see there's nothing here, left or right. So these values, these y values, are not a part of this graph because there's nothing down here. From negative infinity all the way up to negative 2 is when we actually start to see something happen. So because this is an asymptote, these graphs, these pieces of the graph don't actually touch this y value of 2, but it gets really close to it. So to show that it gets really close but doesn't touch and it's not included, we stick a parenthesis there. And then if we kept walking up this graph, we would continue to see a graph forever, all the way up to positive infinity because of these arrows. This is telling us that this graph is going on forever and ever and ever. So our range on this graph is from 2 to positive infinity.